Hello and welcome to the episode 4 where we're gonna continue the book. So on the previous video we discover how to use the print function, also how to use the argument and the loop. So now let's continue and what it is about following. So the subchapter is called finding duplicate lines. So we're gonna learn how to read inside the standard inputs and also maybe how to read a file. Yes, and also how to read a file. So programs for file copying, printing, searching, sorting, counting, and like all have a familiar structure, a loop over the input. Some computation on each element and generation of output on the fly or at the end. Alright, so they directly jump inside an example. So just let's go to the example then. Up. Tutorial. So we are still on the chapter 1 and how it's called, dep1. dep1.go. So package main because it's a program, then import Bufio, FMT, and OS. So Bufio, let's go to the documentation just to make sure. Package Bufio implements buffered input-output. It traps an IO reader or IO writer object, creating another object, reader or writer. That also implements the interface, but provide buffering and some help for textual input-output IO. Alright. So func main, now we are inside the block of the program. Counts make map string int. So make is new. I think we used this. No, we didn't use it yet, but it's quite interesting to know what it does. So we'll probably take a look. Bufio on Google. New scanner. OS std in. So input scan. So while we can read inside the standard input, then we add inside counts input.text. So we get the text of the input and we increment this. I will have to explain this, I guess. So we don't even check the error here. Anyway, for line and range counts. So this you already know what it does. And if the counter is more than 1, it means that we have a duplicate line. So print f, and then we will have also this s and n. Alright, and line. Okay, there it is. So let's go through. So we create how they call that, a map that has for key a string and for value a int. So a string is a bunch of characters and an int is a number. So for example, the map will look like something like that, and then 1, F2, something like that. At the moment we have nothing, So let's continue. So we gonna declare input to be a buffer input output new scanner, which is reading the file descriptor standard input, the file descriptor of the standard input. Then while we can read, we count and we insert so the text received. And if it's the first time, it's gonna be 0. So if, for example, I do counts ABC right now, it's gonna oh, I need to check that. I'm not sure, but I think if we do that, it will give the value 0 at first. And then here, like we are doing plus plus, we increment it, so it's gonna be 1. Yeah. So the first time it see ABC, count's gonna have ABC and then with 1. And if it see ABC again, it's gonna just increment this one. But if we give another one, for example DEF, it will create a new one, DEF, and then like 0 plus plus. So incrementation, post incrementation, so it's gonna be DEF on 1. Okay, let's test this code. One cd that here cd go one tutorial go run, and I think, oh yeah, so if we run this without nothing, it's just going to wait for me to insert things inside the standard input. So for example ABC, DEF, and then I exit with Control C. So nothing to write because ABC and DEF was just written once. For example, now ABC, ABC, DEF, and I exit. Oh, doesn't work this way. Let's try something else. ABC, ABC, DEF. Okay. 9, and then go run dup1. Okay, now it works. Probably Control C was not the good one. Need to check this again. ABC, ABC, DEF, Control D. Oh yeah, it's Control D. But why? I guess this is due to my Control D. Let's just keep that, and we will use the standard input. So as you can see, you can pipe your binary because it's reading the standard input. So go build dup1. Let's call that dup1. Oh. All right. So now we have a binary called dup1 that can read the standard input or can receive also something. So cat is doing the same thing. When you just type cat and you don't give a file, cat is just waiting for the standard input. So if I give it ABC, it will print ABC again. So because cat is just displaying what it received inside the standard input if you don't give any arguments. So here is the same thing. If I run dup1, it's waiting for the standard input. So ABC, I can write whatever I want, and then it waits me to give it back, so to exit it. So it looks like Control C is not the proper way to leave it. And Control D is just adding this character here. But, alright, we can also give it by piping. So if I type an echo, it will just give the content of the echo to dup1. So here, nothing, because it's backslash is to have like a new line. So if I pipe it, then it detects that I have 2 times ABC. So I think it's important to show you how it works a little bit. I'm not sure I can do that, but we will try. I'm gonna print every time we insert something the content of my map here, and then count. Not sure it works, but we will see. Printf and counts doc. So go build the one ABC. So we can see that the map has a key ABC with the value of 1. If now I type ABC again, it has a map. That's the same map, have ABC, but with 2. Now if I type DEF, it has still like the key ABC with the value 2, but now it has also the new value, the new key DEF 1. So that's how they count the duplicate. That's the smartest way. Actually, I would have probably not think about this way, but that's quite smart. So here the key of the map is a string and the value is an int. You can do that with all the type you want, and that exists. What I can explain to this one. So we read the standard input while we have something to read, and when we are done with this, then we loop inside the counts, so the map that we've seen just before, and if so, rewrite the line. So that's the same as I explained on the previous video. When you have a slice, the first one is the index, and the second one is the content of the slice. So here, like counts is a map. So the first one is the key, and the key is the line, and the value is the n, so the size of it. So if we have a count bigger than 1 or greater than 1, then we print the line. So %d is to print decimal, so a int, and %s is to print a string on printf. And \t is just to have this, let me show you again, tabulation. So we have a space here, and then you print the string, and \n is to have a new line. So just to make it more clear. So for example, if I gave also 2 DEF, then we have 2 ABC, 2 DEF with a written line. Oh, I should have removed this counter. But anyway. So that's how they check that we have duplicate line in a file. In a standard input. You can also use, for example, this with a file. So let's compile it again because I removed the logs, debug, printf. We can create a file, vim file.txt. Let's say you have a file called like this. So let's go with a random name, Paul Oregano, James Smith, Rick Morty, and another James Smith. Well, if you have a large file, it can be useful if you want to check that you don't have a duplicate line. And here, then we can just cut my file and pipe it with top1. And then it will say that he has detected 2 lines with James Smith. So what do they say about this? Okay. A map. Oh, okay. I will just read this one because they will probably explain better than me. A map holds a set of key value pairs and provide constant time operation to store, retrieve, or test for an item in the set. The key map may be any type whose value can be compared with ==. String being the most common example, the value may be of any type at all. In this example, the key are string and the value are ints. The built-in function make creates a new empty map. It has other use too. Maps are discussed at length in section 4.3. So That's what a map is. It's for the others who are used to other language. It's like having a dictionary in Python or having a hash in Ruby. So that's quite useful. Then they explain what the code is doing, but I already explained that. Oh, they come up with all the type you can, all the type you can use, all the percent you can use on printf. I'm not sure it's interesting here, but well, I can write it. So %d is for decimal integer, and integer dot x dot o and dot b is probably the same. So hexadecimal, decimal, octal, octal, and binary. So for example, if you want to write it in binary, so 2 in binary is 10. Go compile up, and then cat file. So you have 10. That's the binary version of the decimal 2. All right. So you have F, G, and E for floating point numbers. I let you check the difference between them. It's quite easy. %t is for Boolean, so it will print true or false. %c is for rune, so just one character. Unicode code point decode that rune. All right. %s string, we already see that. %q quoted string, abc or rune, so it will print with the quotes. %v, I used it just for the debug. Any value in a natural format. So when you don't know, it's the first one I come with and use it. %t uppercase, type of any value. You can find the type of the value with this one. And %% is just to print the % sign, because you need to, if you need to write it, you need to specify that it's just that and nothing else. So we are done with this one. Now they go straight to another exercise, another example, dupe2, which is actually able to read also a file. So let's do this example as well. So package main, let's go straight to the main. It will add the import for me. So we have the same thing here, make map string int files. So here we will be able to read the files, I guess. Yes, we read the arguments. If then files smart equal 0, then just count lines. So we call the function count lines with os std in and counts. Okay. If it's not that, then else for so if we have like files, then we will read them one by one with this loop. F error handling os open arg if air not nil, then fmt print fprintf os stdr dupe de %v error, continue, so to exit the loop and continue. Count lines f counts f close. So once we read it, we close it. And this is all for this loop, this block. Now for line and range counts if n. So here is a check for duplicates line. Percentage t backslash n backslash t, sorry, backslash s space return line n line. Okay. And now we have the function count lines. Count lines f s count map string int input Buffio new scanner f for input scan. So that's the same thing, that's the previous one. Count input text plus plus incrementation, and then that's all. We should also have the handling error case. So the function has been written on under the main, and I'm not used to this way, so I'm gonna put the function on the top. So for example, in C, you have to declare first the function above your main. If you use it in this function, it should already exist. So let's keep this way. I prefer this way. So everything. So let's explain everything. So we create the count the same way, a map string int. We take all the arguments after the command one inside files, and we check that we have arguments. If we don't have arguments, then we use the standard input as we previously done with the dup one. But if we have arguments, meaning that someone has written some files probably to be read, then we don't read the standard input and we will read the files. And we will read file by file, and it will check. So it's gonna try to open the file first, and that's here we have the error case handling. So for example, if we take a look to open, you can see it's a function open, take a name string, so the name file, the file name, and then it returns either a file, let's see, well, it returned, let's say, a file, or an error, or both, but well, it's rarely happening. So here, when you declare your variable, the return value so it has two return value, so you can declare two variables at the same time with the same function. So here, either it's gonna give f a value, or either error gonna have a value. So it return open file, so open file, how it works. That's the same way return file, open file probably, it's just here. Open file return either a file or an error. It's gonna test log open, with the permission and everything, and it's called this one. Well, it's going too deep, so let's avoid to read that. So either it returns a file descriptor, either it returns an error. But in Golang, you have to check the error every time you use a function. So right after that, I check that my error is not equal to nil. So if not equal to nil, it means there is a mistake, an error, and that's where we're gonna use fprintf. We're gonna print inside the standard error output. How they call that in English? by pointing to the standard input, standard output, or standard error. So just standard error file descriptor. So we're gonna print inside the standard error the error we just received. So for example, it can be that you don't have the permission to read the file, or the file doesn't exist, and there is many error possible. So for example, you cannot have any file descriptor open anymore because you have opened too much. But if you don't have any, and then continue. So continue is to skip the loop. So we have an error, so of course we won't count the lines of the files because we didn't succeed to open the file. So we continue. It's just going to skip the following and go to the next file that you could have. And if there is nothing, then it just stops. So first file is not possible to read, so you continue. You read the second file, and if there is no problem, you're gonna call the function countLines, which is here. That's take one file descriptor and also a map. So here we send the file descriptor and the map we have, and we don't take the return value. So that's all. And then it closes the file after you have done all the job. Full line, and then we will just print as we did previously the duplicate lines. All right, so let's check that. Go build dup2 dup2.go. Okay, dup2.go. So I don't give any argument, so it reads the standard input. Good. Now let's give it few files. So we still have the file txt. I'm gonna copy it and add few things inside. File to txt and just add another James Smith, for example. And now we can give it arguments to file.txt, file2.txt. And then it will find that I have two Paul Oregano, because in the file 1 I have 1, in the file 2 I have 1, so it's 2. In James Smith, in the total I have 5, because in file 1 I have 2, and in file 2 I have 3. And Rick and Morty, the same thing, is that I have 1 in the file 1 and file 2. It can be used to check you don't have duplicate lines in many files, or just check that you have, or just a counter if you have more. So it's up to you. So it's a good example. Here we discovered the if-else condition block. So you can have either your files have nothing. The length of files is 0, meaning there is no argument. Then you count line with the file descriptor std in. Or if you have arguments, then you go to this block and you will read file by file how many arguments you have, and you will open the file and everything. So for example, if I give a file that doesn't exist here, it's gonna read the file 1, file 2, but will display an error saying open file 3 txt, no such file or directory. So that's a good example of how to handle error also, how to handle error, how to skip a loop, and then that's all you have to learn here. What do they say in the book? So they explain that the %v is to display something when you don't know the type and in the natural format, and that's all. There is nothing interesting here. All right, let's go. They go straight to the next example, and this one they don't write so much. So dup3.go package main front main counts, same thing, make map string int index is not used, file name range os args. Okay, what we're gonna do here, data r io util not discard but read file name if error is not equal to nil. That's quite repetitive, but in Golang you have to always write it. The error case handling is super important in Go and super present, which also showcase that you know what you are doing. So I really enjoy for the moment. I'm not sure after months of coding I will still like it, but it really showcases that you understand what you're doing and you are not just copy pasting something you found on Stack Overflow. Right, dup3 %v backslash error, right, and continue to avoid continuing for line range strings split, so they split all the content of data. Okay, with backslash n, right. Counts line plus the same way. So it's probably to show that it's better to read everything that read line by line. File. Okay, and now we display line n range counts if n1 fmt, so that's the same. Printf %t %s return line n line. Okay, let's try this. So now we don't read anymore the standard input, but they want to probably show that read file is faster. Go build dup3 file on file 2 and file 3, which doesn't exist. dup3 open file, no such file or directory, but it read. Okay, so it's split by, that's interesting, and it's not a behavior that's we actually want, but the split is doing this. So I'm gonna show you how it works. So here we split it. I want you to see, because we have a return line at the end. So for example, if I cat-e my file 1, so we have return line. So $sign is the return line. Cat-e is allowing me to display what is not visible. Man-cat, I want to make sure that I'm not. Display non-printing characters, see the -v option, and display a $sign at the end of each line. So here you can see we use the split function of strings package. That's gonna take all the data we have inside the file. So we read the file with io util, and we put all the content of the file inside data, and then we will split the whole data. And say the separator will be the backslash n, so the return line. So here, like my file, I have some return line, and at the end there is still 1. it will count the next line as an empty line, and that's why when you check the duplicate lines, it considers the last line as a line that it has to be read. So either we remove the the last backslash n of our file, either we make sure that it doesn't read it or doesn't use process this line. So we could do that like counts, for example, if line is not equal to, then we count the line. So we check that. I'm just making sure. Yeah, we just check that line is not an empty line, and if it's not, then we count it. So now it would have the same behavior than duplicate 3. Let's check. So here it is, it doesn't count it. Or either we remove the last backslash n of our file, but it's better to make sure your code handles this case and not the opposite. So what I was going to say was, then yeah, I wanted to show you exactly how it works. So strings lines. Okay. I want to show you what the slice looks like before treating it. So fmt printf lines %v lines. So you can see lines of the first file contain Paul Oregano, James Smith, Rick and Morty. Wait, I think I can do this way to be a little bit more clear. I'm not sure. I think I've already seen that somewhere. No. So it's not this way. Oh, it's not the good one here. Well, no, it doesn't change anything. But well, you have Paul Oregano, James Smith, Rick Morty, James Smith. Well, and it's not displayed, but here you also have the return line. I wanted to show it. Sadly, I won't be able this way. Okay, all right. That's sad. That's unfortunate. Okay. So read files return a byte slice that must be converted into a string, so it can be split by string split. Yeah. Here you can see we not cast, but we specific change this type of data because it's a byte. As you can see here, when I just go over it, it's a byte slice, and we need to, if we want to use the package strings split on, we have to check it, but you can see here, if I go on split, it takes a string, 2 string actually. So we can't like send a byte slice and say, okay, treat this information. You need to change the type of it. So we don't say casting. I don't remember how to say that in English. But we change the type of data to be a string. And then the separator is a backslash n. Alright. We will discuss string and byte slice at length in another section. Under the cover before BufIO scanner, IO util read file, and IO util write file use the read and write method of os.file, but it's rare that most programmers need to access those lower level routines directly. The higher level function, like those from BufIO and IO util, are easier to use. So now they say modify, so the exercise, there is only one exercise on this one, exercise 1.4, modify dup2 to print the names of all files in which each duplicated line occurs. Okay, so exercise modify tube2 to print the name of all files in which each duplicated line occurs. How I'm gonna do that? Good question. So I have a map string int, and he wants me to display modify tab2 to print the name of all files in which each duplicate lines occur. Okay, tab2 counts made. So we map the string and the int. Try was open if continue count lines count. I'm pretty sure it's if they give this exercise it can be really easily done, but in my head I don't come up with like a good solution right now, or maybe it's not that easy that I think. How I can do that correctly? I should create maybe another map with the file. Was F count lines. Modified up to print the names of all files in which each duplicate line occurs. All file. Let's try this. No, because I won't be able to get it. Oh la la. I can maybe use read files. Read file. Golang read file. It's probably not this way it's supposed to be done, but let's try it. So when we print it, what I'm gonna do, just check this. No, it's not here. Read file. Example. Yes, okay. then for args range files io-util read file, then we read the file arg. We need to check that it can be opened, so file descriptor error. Oh, actually we read it here. I should maybe use the same. Let's use the same one and not use io-util on this one. Okay, so range file fr os open arg. Okay, we check that we are able to open it. If we can't, we just continue because we don't want to display it this time. And then we're gonna check for I think io-util would have been better for this case, but anyway, let's continue this way. So we will declare input buff.io new scanner not f. If we succeed to open it, we take all the input, and for input.scan, if input.text equal line found in fmt printf \t found in %s arg. So in the file okay, and then we close f close. I think it should work. That's not the best way, but that's the one that come up in my head right now. So we loop inside all the files when it's done, and so if it's more than one, we loop inside the files, and we will check that, we will read it again, and we will check that the line is inside the file. If it's the case, if we succeed to read one line, which is this, if we succeed to read the line with the content of line, so we found it, and then we display it. And to avoid to display it for if there is like for input scan, so next we should just break the scan. I'm not sure it's like that. Exit loop in Golang break. Okay, so if we find at least one, we just print the file and then we stop reading the file, because if we have like 10 times in the file, we just display found in the file 10 times. So better to skip, and then we close. So it should work. Let's try it. Go build. That's sad we don't have any solution in the book. It should check at the end maybe, but I would have been interested to see how they do that. So now, let's create this. So it found 5 times James Smith, and it found in the file Oh, I need to add some return lines. Okay, like that. There is one here. Okay, so it found 5 times James Smith, found in the file 1, file 2, and then it do the same thing. So it works, but probably not the best way. Let me check if they give the answer of the exercise. I don't think so. And it would be like a huge book if it's the case. So no, maybe it's written somewhere that the exercise is on internet or something, but I didn't read the introduction of the book. So, well, anyway, so we did it. It was the only exercise for this section. So now we will see in the next video how to make an animated GIF. So that's all for this video. Thank you for watching. I hope you still enjoy the content of this playlist and YouTube playlist, and hope it's working for you this way. So thank you. Have a nice day. Bye bye.